Okay, back at number 13. This is just going to happen all day long till I get this done, and I will get it done. So hang with me. I'll be spitting it out section at a time, little bit at a time. Number 13. You first got to decide what function you're talking about here, and this is the absolute value function. So let me draw that in, 0, 0, and then you've got angles here, 45-degree angle, 1, 1, 2, 2, 3, 3, that kind of thing. That's what we're starting with. It's a V. We've got all kinds of things happening to it, and because we have any kind of number up front here, you're going to want to build t-tables for all of this. So let's remind ourselves it's H serve. Let's do the original points here. This is the original. That is 0, 0. Then we've got 1, 1, 2, 2. On the other side, we've got negative 1, 1 and negative 2, 2. So negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. If you put these numbers into the absolute value bars, you get those numbers out. Okay, the first thing we're going to do is the horizontal shift on this. The horizontal shift is always in here within the structure of the function. So it says x minus 1, so you know that's going to be adding 1 to the x-axis, or to the x points. That's the only time we're going to deal with the left-hand column here. So let's do an add 1 to each of these points. The y's will stay the same. The x's, we're going to add 1 to each one. That's this plus 1 in here. That's a liar, always on the x shift, on the horizontal shift. So let's add 1 each time. We're going to get negative 1, 0, 1, 2, and 3, adding 1 to each of these x's. Next thing, you can always do the stretch and reflect at the same time. So let's, again, remember this will be on the y-axis. Let's multiply the y times negative 3, leaving the x's alone, multiplying each y times negative 3. So because that negative 3 sits there, we're multiplying the y's times negative 3. So negative 6, negative 3, 0, 1 times negative 3, 2 times negative 3. And then the last thing that we're going to do here is the vertical translation, the vertical shift. That's a plus 2 on the y. We're going to add 2 to each of these y's. So we get a negative 4, negative 1, 2, negative 1, and negative 4. Okay, let's go graph that sucker and see what it looks like. Now, before we start graphing, remember, it's going to be pulled up a whole bunch. It's going to be made a lot skinnier, 3 times instead of this 1 times. It's going to be flipped around on the x-axis. It's going to move over to the right, and it's going to be moving up too. So it's got a lot of movement on it. Negative 1, negative 4, 0, negative 1, 1, 2, 2, negative 1, and 3, negative 4. Connect the dots, and you can see that's a lot thinner. It's 3 times thin instead of 1 times thin. It goes down. That's what the negative tells you it's going to do, is reverse across the x-axis. It's shifted over 1, and it's shifted up 2. So it's got all kinds of things that are happening to it. Okay, let's look at the remainder of our little problems here. Number 14, first decide what kind of shape it is. Let's see, that's x to the 3rd power. Let me go find our little chart. This is a handy dandy chart for you for sure. X to the 3rd power is the cube. That's going to be the snake charmer snake. Let me show you those numbers so you know, but you're not going to have to create them, I promise you on that. So the cube numbers are, what we're going to use here is negative 2, negative 1, 0, 1, and 2. just the numbers around the origin. Then going from x cubed, let me remind you, it's a snake charmer snake. We're going to cube each one of those. So -2 times -2 times -2, -1 times -1 times -1, 0 to the third power, 1 to the third power, and 2 to the third power. So there's its vertex point. Then it goes -1, -1, -2, -8 down there, 1, 1, and 2, 8. Something like that. Snake charmer. Okay, I'm not going to create t-tables here. Yeah, kind of need to, because in HServe we've got a reason to. Okay, first is the H horizontal shift right in here. You know that it is going to go down 2. So that's a -2. That is, sorry, not down 2. I said down 2. I'm thinking of over here and thinking about this and thinking about how much time do I have left before I get to a rolling blackout again. And I'm cold. So this will be a left shift. Horizontal shift -2 because that's a liar. So let's go through and do those. Leave the y's the same. And let's subtract 2 from each of the x's. So we're going to get a -4, -1 minus 2, 0 minus 2, 1 minus 2, and 2 minus 2. We end up with that kind of situation after taking care of the horizontal shift. We do not have a stretch because we don't have a coefficient in front there. We do have a reflection. Remember, the reflection is going to, you can either think of it as multiplying this line times -1 or just changing those signs. So let me set that up. We're going to do the opposite here. So let me rewrite the x's, and let's do the opposite. 8, 1, 0, -1, -8. The next thing to do is a vertical shift, and there is no vertical shift here. There is no number dangling out around the back side. So let's see what we've got here. -4, 1, 2, 3, 4, and 8, something like that. -3, 1, -2, 0, -1, -1, and 0, -8. So our snake charmer, you can see that our snake charmer has flipped around and he has scooted 2 to the left. There's his belly button. There's his belly button to the left too. So 2 shifts there. It's kind of a cool looking little figure. Okay, let's do one last one of these little guys. We've got a cube root of x. That's our main function. That's our parent function. Let me remind you of what a cube root function looks like. Cube root is the snake in the grass, right there. So how to create this, and you will not have to, how to create this is by looking at the perfect cubes for x. So -8, -1, 0, 1, and 8. They are the y column from the previous one. So the cube root of -8 is a -2. The cube root of -1 is -1. The cube root of 0, the cube root of 1, and the cube root of 8. So those are the numbers that create the graph that is the snake in the grass. So there's 0, 0, -1, -1, 1, 1, and then we go way over here. We go -8, -2, and 8, 2. So he's doing this kind of thing, like that. Okay, let's see what we're going to do to him. In HServe, let's see, do we have a horizontal translation or a horizontal shift? I'm looking at the parent function itself, the cube root of x. No, it didn't change. We don't have a number under there. So we are not going to scoot our snake sideways. Do we have a stretch? No, we do not have a stretch. There's no coefficient right there. So we're getting rid of both of those this time around. Do we have a reflection? Yeah, we do. So remember, on a reflection, you just do the opposite of the y numbers. So let me create that. I'm going to do the opposite of the y's. Keep these guys here. Do the opposites. 2, 1, 0, -1, -2. And then finally, do we have a vertical translation or a vertical shift? Yeah, we do. +2 on the y's. So +2 on those y's. Let me put these back in here. And then let's add 2 here. So that makes that a 4, 3, 2, 1, and 0. Let's graph that. And that is our translated or our shifted snake in the grass, our translated cube root. So -8, +4, -1, +3, 0, 2, 1, 1, and 8, 0. So here comes our snake. Looks like he's burrowing down into the grass. Just the reflection of that. +2 up. Now notice it's not +2 up. It was +2 up from the reflection. So +2 once we reflected it. So you really have to do it in the right order. Okay, the last little bit of 2.5, and then I will stop this recording, and then I'll move to 2.6 and start fresh there. We're naming both of these equations. Let's name this one first. We're a little more familiar with parabola. So let's set it up as, let's say, y equals. We know that parabolas are let's go back to our sheet so I can prove it to you. Parabolas are x squared functions. So let's set it up as an x squared function. Now let's see how far what this guy did. Okay, did he have, let's do HServe again. Did he have a horizontal shift? Yes, he did. He moved over here 1, 2, 3, 4, -4. Be careful there. You know, on the X, it's a liar. So this is -4. We want to put +4 there. We're going to have to put +4 because remember, this is always a liar. To create this, you're going to go the opposite on the horizontal shift. So over 4 to there. Second thing is it stretched? Yours will not be because that's really difficult to determine. Is it reflected? Yes, it is reflected. So put a negative out in front there. And then is there a vertical shift? Does that vertex point move up or down? No, it doesn't. So there's the answer, negative on the x plus 4 squared. They may ask you to change it to a function notation with f of x. One of them does, one of them doesn't of the two problems you have. Those are interchangeable. Y and f of x are the same thing, so be flexible on that. Okay, let's look at our last one. Y equals, we're looking at this function. That's a shoulder. So going back here, the shoulder is the square root of x function. So I'm going to build myself a square root of x. And then I need to see how it got shifted. On the horizontal, did it get shifted? Yes, it shifted over this way. -1, -2, -3, because right there is his vertex point. That's -3. Remember, this is a liar on the horizontal shift. So I'm going to put a +3 under there. Did it get stretched? I promise you these won't, where you have to determine them, they won't get stretched. Did it get reflected? No, that's the shoulder above the bed covers or whatever. So it did not get reflected. Did it get a vertical translation? Yes, it moved up 1, 2. It moved up +2. And remember, that doesn't lie. So stick that out there. And again, they may ask you to do a g of x, or they may even give you the g of x on that one. So it just stays the same. The y changes to f of x, y changes to g of x, that kind of thing. Okay, that is it for 2.5. I'm going to stop the recording. Later on today, I will do a 2.6. I might as well go ahead and do all of 2.6 and 2.7, but I think I'll just wait. So I'll do about half of 2.6 later on.